Be at 3.3, which is just the Vertex form, kind of a review lesson from Unit 1 concepts, but you should have a classwork, which the sub should have given you. It looks like this. So if you have this, you can take notes on your classwork here, and we'll start with the warm-up. So you can read these, pause the video, and then answer these when you have, um, well, answer these and then resume the video when you have answers. All right, so if you've done this, what are the coordinates of the vertex of the parent function? So if you kind of remember, the parent function is just y equals x squared, right? So the vertex of that would be at 0, comma, 0. I'll write on this. Based on the activity that you guys did in the last class, where do you expect the vertex, and really the whole quadratic, it's not just the vertex that moves with these changes, it's the whole quadratic. So where would you expect y equals x squared to move if it was y equals x minus 3 squared plus 2? So hopefully you remember that from Unit 1. That would be a translation, which would be right 3 and up 2. And then last but not least, what is the standard form of a quadratic? Just going back to the first lesson in the unit, and that is y equals ax squared plus bx plus c. And those are your three answers. All right, so today, like I said, it's just a different form of a quadratic. Other than standard form, we have something called vertex form, which is kind of what the last activity worked with as well. Nothing new. It's the same stuff as the Unit 1 stuff, but not every single type of function has a vertex. But with a quadratic, it does, so we call this vertex form. But it's that same HK looking stuff that we had before. So we have y is equal to a, which there's a reason why a is the same in both equations, standard form and vertex form. It means the exact same thing, same number. But then it goes x minus h squared plus k. So this is our HK form or vertex form. They're just kind of telling you how the graph is moved based on these two translations. So it's a different way to express a quadratic in a different format. And this one's a little bit more intuitive for us. We can get a lot more answers just from looking at the equation. Standard form, you got to kind of do negative b over 2a to get vertex, and other things to find out the other characteristics. But this one's a little bit more helpful. So first things first, what are the characteristics of this? And we should probably know these, right? The graph opens up if, well, since a is the same letter, it's recognized as the same thing as in standard form, which is ax squared plus bx plus c. So it's still deciding whether or not it opens up or down. So if we remember, it opens up if a is positive, meaning a is greater than 0. And then it opens down if a is negative, so it'd be less than 0. It's narrower. We do use narrower and wider a lot, but really it's vertically stretched, is what we should say. The graph is vertically stretched if, and if we remember, same thing as what we did before, if a is greater than 1. But we really say the absolute value of a, just because if it's negative wouldn't mean that it's shrunk. It has nothing to do with shrinking and stretching if it's negative. All it has to do with the direction of opening, right? It's reflected if it's negative. And then it's wider if, well, and again, I shouldn't say wider. I'm going to say vertically compressed or shrunk. Vertically shrunk if, and that would be if it's a value between 0 and 1. And again, the absolute value is just there because the negative doesn't have any influence on stretching or shrinking, just the direction of opening. So if we had these two graphs, we probably have an idea of where the vertices are already. This is basically right 1, up 2, right 1, up 2, just that these a values are different. This is a vertical stretch. This one is a vertical shrink. So just a very rough sketch. right? Right 1, up 2, and this one would be vertically stretched, whereas this one with the same vertex is just going to be a little bit wider, right? And just showing you basically what this value, this A value is doing to the graph. Okay, other characteristics, if you're just looking at the vertex form of the equation, right, it's still a parabola shape, so it still has all the same characteristics, so vertex. And obviously, if you're moving right h and then up k or whatever, that's going to be the vertex. So the vertex here is in the equation, which is why this vertex form is so incredibly useful versus standard form when you had to do the negative b over 2a. Here it's just in the equation, right? So the vertex here is hk. And then obviously the equation for the axis of symmetry, because a vertex has to contain the axis of symmetry, would just be x equals h, right? You gotta make sure you write as x equals because it is a vertical line, right? It's not just a point. Other characteristics that we probably have, if you can remember, we always had that y-intercept, and this is the most confusing one probably. The y-intercept is not k, right? This is not the constant. This is not in standard form, so there is no constant in the same way. It's not ax squared plus bx plus c. As you see, there's no letter c and there's no letter b because they don't exist. A is the same because it's the same thing. But you know, it's not like you could just say k is going to be the y-intercept. It doesn't work that way with vertex form. It is still found the same way. Whether it's vertex form or whether it's standard form, the y-intercept is found by plugging in, and if you can remember, it is plugging in 0 for x. Because if you plug in 0 for x, right, if you have a picture of a graph, anything that's on this line is a y-intercept and it has an x value of 0, right? So that's kind of how you found it. So you have to find it by plugging in 0 for x. It's not given to you in the equation like it is in standard form. It's probably the only characteristic that's harder to find in vertex form than it is in standard form. The x-intercept are found by using, I'm just going to name it here. It's really just by solving the equation for 0. But it's a special way we're going to call it. It's called the square root method. Root method. But it's an x-intercept, right? So, you know, it's somewhere here. You're going to set y equal to 0, and you're just going to solve it. And it's not really, it has a special name, but it's pretty straightforward. And that, more or less, is it. The only other thing that we have to deal with is maximum and minimum, but we kind of already talk about that when we have the vertex. So the maximum value, the graph has a maximum when, well, if you think about it, it would have a maximum if the graph opens down, just like the notes we've already done. So when does a graph open down? Well, that happens when a is less than 0, meaning it's negative. Because if it's a negative a value, it opens down, which means it has a maximum. And then obviously it would have a minimum value if the graph opens up, which would just happen if a is positive, so a is greater than 0. Again, a can never be 0 because that would make this whole thing 0, and you just have y is equal to k, which would just be a horizontal line. It wouldn't be a parabola at all. The maximum or minimum value, if you think about it, we talked about it earlier, it's just the y value of the vertex, right? That is the maximum or minimum value depending on its direction of opening. So if that's the case, well, then that's just k, right? It's just taken right from the equation. So you get the vertex right in the equation, you get the axis of symmetry right in the equation, you get the maximum or minimum value right in the equation, unlike standard form when you had to solve for that using negative b over 2a. All right, so here's a typical example, right? You're just going to basically name all of these characteristics just like we did before, but now it's in vertex form, which should make our lives a little bit easier. So the first thing says, does it open up or does it open down? And if you notice, the a value is negative, which just means that the graph opens down. Right, is it narrower or wider? Again, it probably should say vertically stretched or vertically shrunk. So in this case, you see an a value, which is 1/4. It is negative, but that only had to do with up and down. So the 1/4 basically means that it's wider or vertically shrunk or compressed. Right? The vertex is given right in the equation because it's in vertex form. So this would mean right 2 up 5. So that's just, again, that vertex is 2, comma, 5. The axis of symmetry, if we have, let me just see the equation, okay. Axis of symmetry is just the x equals whatever the x coordinate of the vertex is. So in this case, it's x equals 2. The y-intercept, you got to do a little bit of work for. We're going to have to set x equal to 0. It's not 5. That's not true at all. You set x equal to 0, and you get negative 1/4. 0 minus 2 squared plus 5, which 0 minus 2 squared is going to be negative 2 squared, which is 4. All right, so this whole thing is going to end up being 4 times negative 1/4 would just be negative 1 plus 5, which is 4. All right, so the y-intercept is 0, comma, 4. Now the x-intercept, I'm going to scroll down here, I'm going to cut this off. But it's basically you set y equal to 0, and then you would go. So if you think about the equation, right, we'll do it up here actually, it's easier. If I set x equal to 0, you might think, okay, what do I do now? Well, I'm actually going to subtract 5 first. I don't want to FOIL this out because then I'm working the standard form, and then I'd have to factor or do something else that I don't want to do. It's already being squared, and again, to find the x-intercepts, we already alluded to it before. It's called the square root method. So you actually want to keep this part together as long as you can until you get it by itself. So what I'm going to do first is subtract this 5. So that would give me negative 5 equals negative 1/4 x minus 2 squared. So that part's done. Now, if I'm looking at this one, again, I want to get this part by itself. So I'm going to multiply both sides by negative 4, which would give me 20 equals x minus 2 squared. Right? Because if I multiply both sides by negative 4 here, I didn't show it, but I could have, right? All that would do would cancel out this and this, right? Reciprocals. And so at this point, I have what's being squared by itself. So what I want to do is basically just take the square root of both sides. And when I do that, I have to account for plus and minus. So plus and minus root 20, if I take out a square root of 4, that would give me plus and minus 2 and then root 5 equals x minus 2. And then I'm pretty close to getting x by itself. I just need to add 2 to both sides. So I get 2 plus or minus 2 root 5 equals x. And so those would be my two x-intercepts, right? 2 plus 2 root 5 and 2 minus 2 root 5. And again, those are unlike terms. You can't combine them. So that's it. Those are your two x-intercepts. So that, I don't know why this isn't working. So those are your two x-intercepts. So again, we just set y equal to 0, and we square rooted, right? This step right here is why it's called the square root method. Okay, and then last but not least, we have a maximum or minimum. The graph opened down, so that tells us it is a maximum, and then that max value is the value of k, right? So that's 5. It's not the same thing as the y-intercept. We got to solve for that. But here, this one's in the equation for us. It's 5. And that's it, right? So the only ones you really had to do work for was a little bit of work for the y-intercept and some work for the x-intercepts. But everything else is pretty much in the equation. And if we had to graph it, we could do a table right here. So we have x's and we have some y's. You know, just plot your coordinate points and we'll see what we get. So we had 2, 5, which was the vertex. So let me scroll up a little bit. Okay. 2, comma 1, 2, 3, 4, 5. Right there. We did the y-intercept, so that's helpful. We can plug in, and we plugged in 0, and we got 4. So we got 0, comma 4, which means if I have 0, comma 4, if this is the vertex, right, I can use my axis of symmetry, which is this line here, and say, okay, if I have 0, 4, then I also have to have 4, comma 4, which is opposite this point across the axis of symmetry. So that's another point I can do without doing any work. And then, at this point, your x-intercepts are 2 more points, so 2 plus 2 root 5, 2 minus 2 root 5, but that's kind of hard to gauge where it could be. I mean, root 5's, you could probably ballpark it, but I just think it might be easier to pick another point. So, pick a number that's easy to work with. 1's easy to work with, but with the fraction out in front, I'm going to try 6, right? Because if I try 6, I get negative 1/4, and then 6 minus 2 squared plus 5. And then that way it's a little bit easier, because 6 minus 2 is 4. 4 squared is 16, and then that multiplies by negative 1/4 evenly. I mean, you can pick whatever you want. It just have to do with fractions. But if I did 6, I'll get, this whole thing will be 16. Negative 1/4 times 16 is negative 4 plus 5, so that's just going to be 1. So 6, so let me think here. 2, 4, 6, comma 1. And if I have 6, comma 1, right, that's 4 away from my axis of symmetry, so I can go 4 away on this side and get negative 2, comma 1. And then that, it would be the graph. Well, it's pretty terrible, but whatever. That's it, right? And these numbers should be something around 2 plus 2 root 5 over here, then 2 minus 2 root 5 over here. All right. So that's pretty much it for like graphing and identifying the characteristics of vertex form. Another questions that you could have is converting back and forth between one form and the other. So going from standard to vertex is going to be its own separate lesson. We're not going to do that here. But going from vertex to standard, I think is something that we can do pretty easily. So if you had to guess, you might think, well, standard form is ax squared plus bx plus c. So I would probably want to distribute, I'm sorry, not distribute the 2, but FOIL out the x minus 3's, right? And that's exactly what you do, right? You cannot distribute the 2. I'm surprised I said that. But that's it. So we're going to say y equals 2. And basically what we're going to do is we're going to have to just do this FOIL with the x minus 3's. Because if it's x minus 3 squared, it's the same thing as x minus 3 times x minus 3 plus 4.5. And this is actually a pretty basic question. The only part that people screw up is the use of parentheses. So definitely make sure you know how to use them correctly. But at this point, you can just FOIL and go. So it's going to be 2. X minus 3 times x minus 3 is x squared minus 6x plus 9, and then plus 4.5. But again, here we still have these parentheses here. So before you add 4.5, you have to distribute the 2, and then you can add the 4.5. This is 2x squared minus, 12x plus 18, and then plus 4.5. So final answer, y equals 2x squared minus 12x plus 22.5. Right, so this is the exact same thing as this, right? If you graphed one on y1 and this one on y2, it would be the exact same graph spit out on each other. This is just the same equation as this one in standard form versus vertex form. But again, if you did negative b over 2a with this, you would get 3. You would plug it in. You would get 4.5. So like it's the same thing, just different ways to express it. The only other question that you could see based on this stuff is figuring out if a graph is narrower or wider, right? Basically, if it's vertically stretched or vertically shrunk. So, typically, if it goes like, if you think about the parent graph, y equals x squared, that's an a value of 1. And what does it do? Well, like from the vertex, it goes right 1, up 1 to get to the core point 1, 1. It goes right 2, up 4, right 3, up 9. So if it does that, you kind of know that the a value is 1. But here, if you think about the vertex as -2, 4, it clearly doesn't go right 1, up 1, or right 1, down 1, which would just mean the a value would be -1. So you kind of have to figure out what it is doing. So if you're thinking about it, right, you got the vertex, so that's a lot of the equation, right? All you basically need to figure out is one piece. So we have y equals a x minus h squared plus k, right? That's vertex 1. And what do we know from the graph? Well, we know the vertex. It's -2, 4. So that's -2, and that's 4. So we've gotten most of the stuff already just from the graph. So y equals a x minus -2, so x plus 2 squared, and then plus 4. So if you think about what we need to write the equation, right, we're better off writing vertex form than standard form because we already have the vertex. The only thing we need is this a, right? Y is y, x is x. We have h, we have k. The only thing we still need to find is a. So if you're thinking, what can you do to find it? Well, really, what you're going to be stuck with doing is you got to find another coordinate point that's even. So this one is a tough one. These are not exact, but if I look at this one's exact, right? That's a nice, easy point to work with. That is 0, 2. And what can I do with that? Well, that's an x coordinate, and that's a y coordinate. So the problem with solving for this one is I have 3 variables, y, a, and x. Now my final answer has to have x and y, but a needs to be some number. But if I plug in 0 for x, because it is an x coordinate, and I plug in 2 for y, because it is a y coordinate, I will only have one variable left, which means I can solve for it. And that's exactly what I do. So I say, okay, 2, since that's the y coordinate, equals a, and then the x is 0, so 0 plus 2 squared plus 4. And then basically 0 plus 2 squared is going to be 4. So I'm going to get 2 equals 4a plus 4, which I'm running out of room. But, you can't combine these. They're unlike terms. So I'm going to subtract the 4 off, which gives me -2 is equal to 4a. And if I divide by 4, I get -1/2 equals a. And that's basically going to be my answer, right? So I use 0, 2, and that's what I get. So again, that's not the final answer. The final answer is to write the equation of this graph. So that graph is going to be y equals -1/2, because that's the value of a we solved for, and then my vertex, x plus 2 squared. Make sure you write squared. That's like one of the most common mistakes I see is they don't square it. And then the k value is plus 4. And that's it, right? Check it. That vertex is definitely -2, 4. Plug it in, any other point. If you plug in 0, do you get 2? Well, yeah, you should, right? So all of that stuff is a good check. Okay, so what I want you guys to do, it's not a lottery question because I'm not there, sorry. But I just want you guys to do these 2 questions, so you can pause the video and do this. I want the equation of this graph, and then when you're done, the equation of this graph. And then you can resume the video when you finish. All right, so this first one's interesting. The vertex is definitely down here at 3, -2. But I mean, you can plug in, this point right here is 0, 7. I would plug that one in. You could have also plugged in maybe another point if you could find it, but the y-intercept is easy to see. So, but I mean, if you did the whole thing, I think you would end up with a is going to be equal to 1. But if you think about it, you didn't really need to do it because you can see here, if this is 3 comma negative 2, it goes right 1 up 1. You know, it goes right 2 up 4. Right? That's exactly what the parent function does, which has an a value of 1. So if you can see that, and this graph doesn't have the grid, so it's harder to see, but it does go right 1 up 1, right 2 up 4, which just means that the a value is going to be equal to 1, right? But it doesn't hurt to plug this in for x, plug this in for y, and actually solve for a, which we just did in the last slide. But I think your final answer ends up being here, since the a value is 1, as y equals 1. You don't need to write the 1, though. It's just going to be x minus 3 squared and then minus 2. Right, 3 down 2. And that's it. This one here is not, right, it doesn't go right 1, down 1. It goes right 1, down maybe 3. But that doesn't, you know, as long as it doesn't go right 1, down 1, you can't say the a value is negative 1. So you're going to have to solve for it. So this vertex right here looks like it's at 1 comma 1. So we got 1, 1. And I'll use the y-intercept again at 0, negative 2. And I'm just going to solve it for a, because that's the one thing I don't know. So I'm going to say, okay, the vertex is 1 comma 1, so it's going to be a, x minus 1 squared plus 1. Now I know that a is going to be negative because it opens down, but I don't need to put a negative here. It'll work itself out when I solve it. So now I'm going to plug in negative 2 for y and 0 for x. So I'm going to negative 2 equals a, and then x, oops, sorry, not x, I want to use 0. 0 minus 1 squared plus 1. And basically, if I subtract the 1 off, I'll get negative 3 equals 0 minus 1 squared is just going to be 1, so negative 3 equals a. And that's it. So put it into an equation, and I get y equals negative 3 x minus 1 squared plus 1. And that's it. That's a negative sign here. Negative 3. All right, so if you did that, then you are good. If the video is done, you still have some class time left, you can, we're going to skip that. But if you still have some class time left, go ahead and start the homework, which is on Schoology. Thanks, guys.